In section 9.2, we're going to talk about regular Markov chain. But before we start, we need to explain something called the irreducible Markov chains. Irreducible is simply when all the states in that matrix communicate with each other. So it's easier to think about it as connectable. All the states connect with each other. So let's take this matrix right now. 1, 2, 1, 2. Are they connecting with each other? So let's start here. This is 1, this is 2. From 1 to 1 is 0.24. From 1 to 2 is 0.75. From 2 to 1 is 0.65. And from 2 to 2 is 0.35. Connectable means if you are in 1 and you want to go to 2, can you come back? If you are in 2 and you go to 1, can you come back? So they all connect with each other. If they are connectable, if the whole thing connectable, then it is irreducible. So the answer is yes. So think about it like a traffic flow. Can you come back when you go to any state, when you start from one state to another? Then it is connectable. Let's take this one. 1, 2, 3, 1, 2, 3. 1, 2, 3. By looking at this matrix right here, you can tell it's not connectable. But the easiest way to see if it's connectable or reducible is to draw the transition diagram. This is the benefit of the transition diagram right now. 1 to 1 is 0.2. 1 to 2 is 0.4. 1 to 3 is 0.4. 2 to 1 is 0.3. 2 to 2, there is no traffic right here. 2 to 3 is 0.7. Now 3 to 1 no traffic, 3 to 2 no traffic, 3 to 3 is 1. 100% of the traffic in 3 goes around itself. So let's look at it right now. If you are in 1, can you go to 2? Yes. Can you come back? Yes. If you go to 2 and you go to 3, can you come back? No. From 1 to 3, you get stuck in 3. Why? Because 100% of the traffic in 3 goes around 3. So a hint here, anytime in the diagonal you see 1, it means 100% of the traffic around itself. If the 1 is here or there, automatically it is not connectable. If the 1 is here or anywhere else other than the diagonal, then more works to be done. So here is the 1 between 3 and 3, so 3 to 3. So the answer is no, it's not connectable, it is not irreducible. That's the benefit of the transition diagram, where you can see why it is not connectable. Here is another example to decide if this matrix is connectable, irreducible, or not. By looking at those numbers, it's really not easy to decide just by looking at them that it is irreducible or not. At least if I see an element in the diagonal equal to 1, I can tell right away it is not connectable. I don't see an element equal to 1, so the best way to check my answer or to check the matrix is connectable or not, it is to draw the transition diagram. Before we even start, make sure no element is negative and the sum per row is equal to 1 and no element more than 1. So here is step number 1, 2, 3, 1, 2, 3. 1, 2, 3. From 1 to 1 is 0.6. From 1 to 2 there is no traffic. From 1 to 3, 0.4. From 2 to 1, 0.2. 2 to 2 there is no traffic. From 2 to 3, 0.8. 3 to 1 there is no traffic. 3 to 2 there is 0.8, I'm sorry. And 3 to 3, 0.2. Now, if you look at all those arrows right there, if you start with 1 and you want to go to 3, you can go back to 2 and go back to 1, to where you started. If you start at 2, you can go to 1, you can go to 3, and you can come back to where you start from. Again, there is no way where you can go anywhere without being able to come back to where you start. If I start with 3, I can go to 2, I can go to 1, and come back to 3. So all those states are connectable. So is it irreducible? Yes, it is. It is irreducible. Now, the reason why we are doing this, because it's a step to check if the whole chain is regular or not. Here are the rules. We draw the transition diagram to see if it is connectable or irreducible. If it is not connectable, then it is not regular. Rule number 1, if it is not connectable, then stop. It's not going to be regular. We have to have a regular Markov chain in order to apply what we will learn later called the Markov chain and steady state vector. So how about if it is irreducible, it is connectable? Are we done? No, we're not. We have to go to the next step. If at least one element diagonally is not equal to 0, like I have here one element here and one element there, then it's regular. So if it is connectable and one element is not equal to 0, then we're done, it is regular. If it is connectable and everything here on the diagonal equal to 0, then we multiply it by itself. Could be twice, 3 times, 4 times. If all elements become positive, then it is regular. So rule number 1 controls the other rules, and the best analogy I can give you here is, suppose you are going to be voting on a voting day. The rule in United States, in order to be voting, you have to be an American citizen. If you are not an American citizen, don't worry about the other rules. But if you are American citizen, you have to worry about other rules, like, are you over 18? Did you register to vote? But again, the first rule, if it's not applied, you don't have to worry about the other rules. So those are the rules to make it regular. Let's check more examples about it. Here are 3 matrices. The first one is all positive, no one diagonally. I can tell from looking at it that it is all connectable. It is connectable and it is regular because no zeros, not all the diagonal element equal to 0, and it is definitely connectable. Now we go to number to B here. I have a 1 right here, not diagonally. If the 1 was in the diagonal, we stop because it's going to be not irreducible, not connectable. Can you tell if it is regular or not? Notice here one element in the diagonal is not equal to 0, so it should be. But if you are not very sure about your answer, why don't you draw it? Here is state number 1, 2, state number 1 and 2. Here is 1, here is 2. From 1 to 1, 0.5. From 1 to 2, 0.5. And from 2 to 1, 1. So you notice there is traffic all around. You don't get stuck in one node. So it is connectable. And at least one element is not equal to 0, then it is regular. The third example here, notice where the 1 is. The 1 is in the diagonal. So it is not connectable. If it's not connectable, which means not irreducible, you don't have to continue. Just like the example I gave you, you're not American citizen. You don't have to worry about the rule of age or if you register or not. Not connectable, automatically not regular.